Yeah. Okay. Hello, everyone. Good evening. Welcome back to our weekly series where we talk about the various projects. Now, in front of you, today we have one project: optimize energy consumption in steel manufacturing plant. Okay. So let me introduce myself first. Myself, Kunal Gokul Borse, and I'm working as a trainer at 360DigiTMG and also a junior data scientist at AiSPRY. So, in this slide, let's talk about one scenario. So here we have two people who are competing for the job, Mr. and Mrs. A and Mr. or Mrs. 360. Okay. Uh, so the Mr. A is trained at XYZ Institute, who worked on a dummy projects from Kaggle, GitHub, etc. And Mr. 360, who trained at 360 DigiTMG and work on real-time projects. He attended a daily stand-up calls, created end-to-end data pipeline, deployment on premise and on cloud, attended client meetings, and research paper published in international journals. So here you can see the clear difference between these two, and you can take a guess for yourself as who will get shortlisted for the job and whose resume will get shortlisted. Okay, so without any delay, let's move further with our project. Okay. First, let's understand how steel manufacturing process happens through this diagram. So in the steel manufacturing, we start by preparing the raw materials like cooking coal, iron ore, and all other scrap materials. So cooking coal is turned into a coke, which is used in a blast furnace along with iron ore and sinter to make them molten iron. So this molten iron is then transferred to the electric arc furnace, where it melts with the scrap metal and other materials like HBI and DRI. HBI means hot briquette iron, and DRI means direct reduced iron. So in the electric arc furnace, we carefully controls the temperature and energy to melt the materials properly. So the chemical analysis of the steel happens in the electric arc furnace, where we check and adjust the elements like carbon and silicon to ensure the steel is a right type or not. Once melted, the steel moves to the ladle furnace. So for the small adjustment to the chemical mix to get the right steel grade. So after that, the steel goes through the vacuum degasser, which removes any unwanted or dissolved gases trapped inside the steel. So finally, steel is poured into a mold to cool down into a shapes like billets or slabs. Okay. So these are then processed in a rolling mills to create a steel grades. Grades means different types of steel products. Okay. Now let's understand the business problem. Uh, one of the top steel manufacturer in India is facing a problem. They are having trouble figuring out which steel grade are most efficient in terms of energy consumption, production speed, and overall production. Because they don't have any accurate way to classify and identify the best steel grades. So they are not able to optimize their production process. This means they are not using their resources as efficiently as they could, which makes it harder for them to cut costs and improve their operation. So, in simple terms, if they could better understand which steel grade are the most efficient, so they could save the energy, speed of production, and improve the overall quality of the steel grades. So, leading to a lower cost and better performance. The objective is to maximize the product efficiency. The constraint is to minimize the energy consumption and cycle time. And business success criteria is to improve the production efficiency by 20%. And machine learning success criteria is to achieve at least 90% of model accuracy. And economic success criteria is to achieve a cost saving up to a $250,000. So So this is the high-level architecture diagram that provides a pictorial overview of this project flow, which follows the CRISP MLQ methodology. So the first stage is a business and data understanding, where we understand the business problem and we collect the data and store the data in the database. So next, we perform the exploratory data analysis and data pre-processing or data cleaning. So after cleaning the data, we store it back in the database again. So we then proceed with the model building and evaluation. So for that, we split data into a training and testing. And then the final stage is model deployment. For that, we choose a best model, and on that model, we deployed using a Streamlit framework. So let's understand about the data. So we had a structured data set in CSV format with 2059 rows and 51 columns. It includes columns such as steel grades, uh, steel batch ID, and scrap materials like BSM, TP, REMED, as well as energy consumption, cycle time, production, and chemical composition columns like silicon, magnesium, phosphorus. Okay. Since there is no output variable in the data set, so the data set is unsupervised. Okay. So, and it is also a primary data because it is collected from the client side. Okay. Then after that, we perform the exploratory data analysis. In that exploratory data analysis, we perform a first movement business decision, which is measure of central tendency, in which we calculated mean, median, mode. In the second movement business decision, which is a measure of dispersion, here we calculated standard deviation, variance, and range. And third movement business decision is skewness, and fourth movement business decision, kurtosis. Here we calculate the pickedness and tailness of the data set. Okay. After that, we move further for the data pre-processing. So in the pre-processing, we apply the typecasting, missing value imputation, then outlier detection. Okay, so in the outlier detection, we use pincerization method using the box plot. So in this screenshot, you can clearly see the outliers for each column. How many outliers are there for each column? And these are the results of outliers treatment using IQR methods. Okay. So now come to the model building phase. Okay. So as I already mentioned, we did not have an output variable. So our data was unsupervised. So we applied unsupervised learning algorithms like DB-scan clustering, k-means clustering, agglomerative clustering, mean shift clustering, and GMM clustering. Okay. To cluster the grades, we use some key features such as energy consumption, total cycle time, and production. So based on these features, we define two classes: optimal grades and non-optimal grades. Okay. For that, we have some condition. Okay. So here you can see if the energy consumption and total cycle time is less than the 75th percentile of that own column, and the production is greater than 75th percentile. So these type of grades comes under the optimal grades. And for the non-optimal grades, if energy consumption and total cycle time is greater than the 75th percentile of own columns, and production is less than the 75th percentile, is that grade is a non-optimal grade. Okay. So among all these models we perform, the k-means clustering perform the best model. Okay. Achieving the highest seal-out score. After clustering, we obtain the new output variable with two classes, optimal and non-optimal. This means we converted unsupervised data into the supervised data. Okay. So next, we use this labeled data to train the supervised classification models to predict whether the grade is optimal or not optimal. So we applied models like decision tree, random forest, support vector machine, XGBoost, k-nearest neighborhood. So after evaluating, we got XGBoost. Okay, XGBoost was the best model, achieving the 99% of accuracy on both training and testing data. Okay. So after that, we selected the best model for the deployment using the Streamlit application, a Streamlit web application. So here, user can upload the data set and the model will cluster the grades based on our previous logic. Okay. It will then predict whether the steel grade is optimal or not optimal. Okay. So here you can clearly see the results are optimal or non-optimal grade. This is predicting on the new data set. Okay. So, so using our solution, so client predict the performance of their upcoming production. This allows them to produce only those grades that are optimal. Optimal means which consumes the less energy, which takes less time for the production and gives the higher production and also improving the efficiency and the quality of the grade. So this is all about the project. Thank you. Thank you, everyone.